Okay, good morning. So let us start today's lesson. I want to continue with the exponents. So if you remember last time, we just started defining what is the meaning of a power. So I told you that A is a real number. This I read it, A belongs to the set of real numbers. Or I can just say simply that A is a real number. And I told you that let us first assume that N belongs to the set of natural numbers. I will consider natural numbers starting from 1, 1, 2, 3, 4, etc. And then I told you that if you see some symbol like this in mathematics, it means A itself. But if you see that A to the n, to the nth power or to the nth, when n is greater than or equal to 2, whenever you face this symbol, they mean to write A and multiply it by itself n number of times. Okay? So that was the definition. So this definition is not something very deep or conceptual. It's just a symbol notation that I'm introducing you. Instead of writing this big mess, just compactly write to the nth. Yes? That's how you read it. Or A raised to the nth power. So A to the nth is probably easier to read it in that way. Okay, so for the time being, let me just write some exercises here for you, and then I want to wait for you. These are very, very simple ones, but I just want you to answer these questions. So you can start with me. You don't need to waste the time. I want to see how do you continue with these calculations. I want you to write the final answer to each one of these items that I have here. Okay? So you just start doing them. It's very good to take a pen and paper and try to write them down, work them out. Okay? So 2 to the 4th. Let me write one more. Okay, so I pause the recording, wait for you a little bit, and then we continue. Okay. Yeah, please let me know if you have real troubles, but let me just explain. So you see 2 to the 4th. This is a symbol sitting for something, so it means that I have to write it 2 times 2 times 2 times 2, and then I have to calculate this. Either I can do it in my head or I use my calculator, okay? So then if I multiply these numbers, what is the answer? It's simply 16. So 2 to the 4 is 16. If I want to do this, I would say that by the way, what was the name of A? It was the base. This was the exponent, and the whole package is called the exponential, an exponential, or a power. So here I have a power. The base is 2/3 and the exponent is 3, yes? So the base can be any number that you like, but for the time being, I am just considering the cases where n, the exponent, is a positive integer, is a natural number. So this means that I have to repeat the base 3 times here and multiply them together. And of course, you already know the rule for multiplying the fractions, so I multiply all the numerators, so it becomes 8. And then if I multiply 3 by 3 by 3, it becomes 27. So if you really want to calculate this symbol, that's another alternative way of writing 8 over 27. And I go here, this means that the whole package of minus 3 should be raised to power 4. So it means that I have to write minus 3 4 times, multiply them together. And then minus 3 times minus 3 is positive 9. Positive 9 times minus 3 is negative 27. Multiplied by that one, it becomes positive 81. And please interrupt me whenever you don't understand something, okay? Here, minus 3 to the 3 is the same story, but I have to multiply them 3 times. Then I see that at the end, I will end up with a negative number. So you can also discover a rule for yourself. If I have a negative number to some power, if the power is even, I will end up with a positive number. If the power is odd, I will end up with a negative number, yes? If the whole package is supposed to raise. These are the rules that you need to know in your mind. But what is the difference between this and that? Here, minus sign is also being affected by this power. But here, minus sign is after you apply and calculate this. Minus sign comes later. Yes? So that's the difference between this and that, even though they are very similar. So if I ask you to answer this, you need to put a minus sign because of this minus sign. Now forget about this minus sign because you have already considered that. And then you are facing 3 to the power of 4, which you know what to do. You multiply 3 4 times. So if I ask you 3 times 3, 9 times 3, 27 times 3, 81, and then you have a negative sign here. So you end up with minus 81. And if you compare this one with that one, you see that they are quite different. One of them is positive 81 and the other one is negative 81. And if I do the same thing here, I will write it in this form. And then you see that it becomes minus 27. So in this case, the answers are the same, even though the intermediate steps are different. You see, if I ask you, is this identical to this? You say no. There is a difference between this one. Here you see minus sign 3 times. Here you see minus sign 1 time. But the final answer is the same, even though intermediate steps are different. Here, the intermediate steps are, of course, again different, but the answers are also different. So you need to be careful about these small points. Okay, now if I want to calculate this, I have addition between two numbers. I want to add them up, so I need to know this number, I need to know this number, then I know how to add them. So automatically, you are giving priority to the power calculation. So you calculate this power first, or in parallel, and then when they are clear, then you add them up. So if you have powers and if you have addition or subtraction, that priority is given to the powers. So this becomes 4 to the power of 3. So if I want to write it, I would write it as 4 times 4 times 4 plus 3 times 3. I hope that in good school and you learn that the priority, here I have a priority. In principle, I have to put a pair of brackets around here and a pair of brackets around here, but that is convention to simplify writing things. If I have, for example, if I ask you to calculate this, what is the answer to this? Yes?
14.
It's 14. Even though it seems a little bit ambiguous. It seems that it is not clear because how many operations do I have?
2.
2 operations. And then I haven't used pair of brackets. Okay? So it means that should I do this one first or should I do this one first? And the answers are different. Yes, because if I do this one first, it becomes 5 times 4, which is 20. If I do this one first, 2 plus 14, it becomes 2 plus 12 becomes 14. Yes? So which one is correct? If I write it in this way, this is the correct answer. If I write it in this way, this is the correct answer. But if I am a little bit lazy and I do not put explicit brackets, then there is a convention here. There is some agreements between mathematicians, even though it's not mentioned all the time, that if we write this, we mean this. And they say that if I have addition and addition and multiplication, the multiplication by this conventional rule has priority over addition and subtraction. Yes?
Isn't multiplication and division equal.
Yes, they are on the same footing. Then you start from the left-hand side to the right-hand side by convention. So might be we have different conventions in different contexts, but yes, you are right. Yeah. So this paying attention to priority of operations are important. So here I haven't seen students make mistakes, but I have seen some students make mistake if the exponents are the same. So I have seen some students, when I give this, they add 4 and 3 together first and then raise it to power 2. Okay? So they say 4 plus 3, 7, 7 to power 2, 49. But this is wrong, yes? Because the priority is not with the addition. The priority is with the power. Yes? Why is that? Because when you write it, it becomes product, it becomes multiplication and addition, and you know multiplication has priority over addition, so we have to do that one first. Okay, so let me write this, so it becomes 64, because 4 times 4 times 4 is 64, 3 times 3 is 9, and if you add them up, it becomes 73. And here, 5 minus 2, which one should have been? So you have a lot of operations here, 2 subtractions, 1 additions, and 2 powers. So what I have to do first? I have to start with pair of brackets, yes? So here I have to write 5 minus 2 first, which is 3. And then I put 3 on top, plus 8 minus 7 is 1. And then I have to put 100 on top. Okay? And if I continue, 3 to the power of 3 is 3 times 3 times 3. Of course, 1 to the power of 100 means 1 times 1 times 100 times. But what would be the answer at the end? 1. It would be 1. So if you don't mind, let me write 27 plus 1. It becomes 28. Okay, can you answer this question? What would be 1 to the power of 1000? It's 1. What would be minus 1 to the power of 1000? It is 1 or negative 1?
Negative 1.
No, positive 1. Because minus, it means minus 1 multiplied by minus 1 multiplied by minus 1. How many times? 1000 times. But 1000 is an even number, yes? So at the end it would be 1. Yes? But tell me, what is this one? Minus 1 to power 1000. This is minus 1. Okay? And what would be minus 1 to the power of 999? It would be minus 1. What would be minus 1 to the power of 900 in this way? It's minus 1. So you understand what's going on. Yes? Is that understandable for everyone? Yes. So, so one of the numbers that we can raise it high, very high easily is just 1 and minus 1. So you don't need to be worried. Another number is 0, of course. 0 to any power is 0. By the way, I just want you to pay attention. Sometimes you have seen probably in the news or newspaper or somewhere that something is growing exponentially. Yes? So that's an exponent. I told you that. This is an exponent. The whole package is called an exponential. Exponential growth is actually very famous. It grows up very, very fast. So now that you have your computers probably with you, let us do some calculations. This is a very good idea, by the way. So let us see how big this number is. So I want you to motivate you a little bit about the largeness of this number. When I say 2, so 2 is not a very big number. 64 is not also a very big number. If your salary is 64 crowns per month, it's nothing. Actually, you are completely poor, yes? So 64 is not a big number. 2 is not also a big number. But 2 to the power of 64, let us check. Let us come with me. I have some of them in my memory. So 2 to the power of 1 is 2. 2 to the power of 2, 4. To the power of 3, 8. The next one, 16. The next one, 30. The next one, 64 is already 2 to the power of 6. 2 to the power of 7, 28. 2 to the power of 8, 256. 2 to the power of 9, 512. 2 to the power 10, 1, it's not still a big deal. 2 to the power of 10 is 1024, and the next one 2 to the power 11 is 2096, or something like that. Yes? So they are not that big. But let us see, if I continue this process, and I reached, for example, to 2 to the power 64, I want to have a feeling how big that number is. And to give you a right feeling, I want to ask your intuition about my question. Yes? So, this is an A4 paper. Yes? This is an A4 paper. The thickness of this is not that big, so it's not very big. If I want to have approximate, have you seen A4 package papers? Yes? So, they have 500 of these papers inside the package. And I think if you agree with me, this is of this thickness. One of those packages, yes? Around, let us call it 10 centimeters. Do you agree? It's a rough approximation, yes? Yeah. So if I have 500 pages of this book on top of each other, you have a feeling, you have seen it in shops, it would be around 10 centimeters. Only 500 of them, yes? So that's a good approximation. If I have 500 pages piled up on top of that, it would be just, the height would be up to here somewhere. Let us call that 10 centimeters. Yes? Now I'm asking you, instead of putting, for example, if I ask you if I put 1,000 of these pages on top of each other, the height of this pile of papers would be approximately 20 centimeters. Yes? Yes, it's a rough approximation, but it's a good approximation. It's not far from reality. Now my question is that, what do you think if I have this many papers and I start piling them up one on top of each other? This would be a tower of papers. Yes? What is your intuition about the height of this paper tower? Yes, we want to see how this will go. Okay? So, you know how to calculate. Can you calculate this? How should I calculate this? I want to understand the thickness of 2 to the power of 64 pages piled up on top of each other. So let us answer this question. How can I calculate this? Tell me. How can I calculate this? Everyone should know. If I ask you what is the thickness of 1,000 papers, you immediately answer 20 centimeters. How did you understand? You divide the number 1,000 by this number, it becomes 2, and then you multiply 2 here. That would be the thickness of 1,000 pages. Is that understandable? If I ask you what would be the thickness of, for example, 1,500 pages, what do? You divide this number by that number, it becomes 3, and multiply it here, it becomes 30 centimeters. Yes? Now I am asking you the same question, not for this number, not for this number. I am asking you for this number. So what you need to do? Tell me. Yes?
Divide by 500.
Yes? And? Multiplied by? 10.
Yeah.
Multiplied by 10. What would be the unit of measurement here? Centimeters. Okay? And then if you don't mind, can I simplify this 10 by this 500?
Yes.
This is 1 times, this is 50 times. Do you agree? Yes. So the height of this tower by calculation is 2 to the power 64 divided by 50. How much? Centimeters. Okay? Yes? Let me, usually centimeters is not a good unit. Let us turn it into meters. So what should I do to turn it into meters? Yes? Divide by 100, so it becomes how much? Can you divide this number in your head immediately by 100? It becomes how much? 5,000, yes? I divide this number by 500, by 100. These calculations you should be very quick at. If I have a fraction and I ask you to divide it by a number, what happens? This becomes A over B multiplied by 1 over C. Do you agree? And then what happens? It becomes A over BC. So it means that if I want to divide a fraction by a number, what I need to do, I keep the numerator, but I multiply the denominator by that number. Yes? Is that understandable? So I wanted to divide this by 100, so I multiplied 100 by the denominator. Is that understandable? So this is meters. So Eiffel Tower is 330 meters. Yes? Approximately. 330 meters is Eiffel Tower. Okay. I think the highest one the highest tower that we have in the world is Burj in Dubai, yes? So it is around 900 meters, a little bit less. But so Eiffel Tower is that one. I don't know. This Burj Khalifa is approximately 900 meters. Do you think this paper tower that we make by piling it up would be taller than that, or taller than that, or how much would it be approximately? This example is a good way to give you the feeling how big that number is. Is it very big? Is it very small, or whatever? Because you remember, we calculated 2 to the power of 10. It was just 1,024. It was not that big deal, yes? Yeah, it was around 10 centimeters. 20 centimeters, yes?
I think the height might reach space.
Yeah. So his intuition is that we have to go to space. Yes? What is your intuition?
It'll probably be a few million times as big as that one.
Okay, a few million times. So probably, we will go to space, yes?
Or like beyond space.
Yeah, beyond space, yes. So how do you think that these are realistic? How these guesses are real? Yes?
What comes after a trillion?
Quadrillion? I don't know exactly. Yes? No, but give me some measure. For example, should it be higher than that one? So they are telling that you have to go to space. So if you start piling them up, you finally end up in the Mars, or where? Do you think we reach the sun? By the way, what is the distance from the Earth to the sun?
Like 300,000 kilometers.
No, 300,000, no. That is from Earth to the moon somehow.
Oh, yeah,
To the sun is 150 million kilometers.
Oh, yeah,
Yes.
I was thinking of the speed
Yeah.
of light.
No. But the guess is correct. More or less, the distance from the Earth to the moon is around 383 or something
Yeah, but
meters.
isn't the speed of light like 300,000
Yes.
kilometers?
Yeah, that's also a coincidence. The numbers are almost the same.
Yeah.
Yeah. But for this, 150 million kilometers. Okay, but now I need your GeoGebra. You have installed GeoGebra on your.
Yes.
So please open it up and punch this number there, and it will give you a number with. So I think you need to go to CAS view. Should I open it, or you can manage it yourself? So remember that number. So the unfortunate thing is that when I have to connect, then I will lose connection to. Let us see how we can do it using GeoGebra. And I told you, please install GeoGebra Classic 6 or 5, preferably in English, on your laptops. If you haven't done that, just Google GeoGebra Classic 6, and then it will give you a link to download. It's free. Download it and keep it on your computer.
There's 15 zeros.
So, yeah, we have to wait a little bit. The first thing comes here is this one, the second one. Okay. Oops, I need to take this away. It was in Persian. So I go here to GeoGebra. I'll just open it. I think it's suitable to go to CAS view here. I don't know, I haven't done this calculation before. What was the calculation? I want to go to, I press this one to go to height, so it is 64.
Yeah.
And then I go down, I return back, and I divide it by what? 5,000. So that's my number. Yes? This is in meters. Let us do it in kilometers. If I want to do it in kilometers, what should I do? I need to add 3 more zeros in the denominator. Yes, because I have to divide by 3 again. Agree with me or not? Okay, that the hard part is that this is now in this, not in the frame. Okay, forget about it, I cannot do anything. So I put 3 more zeros. Now this is expressed in kilometers. Yes? So let us see if the GeoGebra is capable of giving you that. Oh, it's not simplifying things. So I don't know how I should evaluate this. So might be I need to be able to approximate this. Yes, so that is the approximate number. Yes, this is in kilometers. Yes, and then so your guess was correct. So if I go back and I divide this by I divide this number. So let me divide this by 150 million kilometers. Okay, 150 million kilometers. Let us see what happens. So it would be, so your guess was correct. It would be 24,595 times between the distance from Earth to the Sun. Yes? So is that understandable? So now I just want to feel. The paper was so thin, but even though the paper was so thin, if I pile up that 2 to the power of 64 numbers on top of each other, the height of this paper tower would be approximately 25,000 times larger than the distance between the Earth to the Sun. Yes? So do you understand? That's a huge, huge number. The distance from the Earth to the Sun is 150 million kilometers. And as your friend said, in 1 second, a photon of light travels 300,000 kilometers. But for a photon to reach from Earth to the Sun, it takes 8 minutes. Okay? And now multiply 8. So if you have a photon of light here and just shine it up, you need to multiply this number by 8 minutes approximately. Let us see. If I multiply this number by 8 minutes, then I divide the whole package by, if I divide this package by 60, it's very interesting. Yes, it takes nearly 3,200 hours for a photon of light which travels 300,000 kilometers in 1 second to reach the top of that tower. Yes? So these are the things that you can convince yourself of by just simple calculations. So please start respecting 2 to the power 64. Yes? 2 to the power 64 is a huge number. So even though 2 to the power 10 was not that big, 2 to the power next one is not that big, but they start, if this is the increase, this is an exponential increase. When you go high, it suddenly starts increasing very, very fast. So now do you have a feeling for how big 2 to the power of 64 is? Yes? And now, this is a good feeling. I don't know, I'm just trying to compare this with reality, what's here. And now you can also think, so huge number, how many digits does this huge number have? How many digits?
25 perhaps.
Yeah, it is. I think it's below 20. So if you just write 20 digits, it is so big number. You might think that it should have 1,000 digits. No, a number with 1,000 digits is actually much, much bigger than this number. So I don't know if GeoGebra is capable of doing that. Unfortunately, this part of this is not being in the frame, being recorded. That's a little bit unfortunate. But another thing that I really recommend you to learn, this is called Wolfram Alpha. Just do it right now, Wolfram Alpha. It's also free. So you go here, Wolfram Alpha. More or less you can type whatever you like to here. So let us see, 2 to the power of 64. This Swedish keyboard is a little bit strange. I don't know how to, okay, that's correct. So, and then if I press it and then press equality, so it gives you a lot of questions. So you see this is coming. So if you start counting the number, and by the way, it's quintillion, yeah, so that is your question here. So it's giving you a lot of information. 20 decimal digits. So a number with 20 digits that you can immediately write, 1, 2, 3, up to, I don't know, whatever. So it is so huge number. Yes? And I hope that you are also familiar with this scientific notation, yes? So writing in powers of 10, okay? Okay, so that is also a very, very important website that we will use. Everything is free and it gives you a lot of good calculations. You can do a lot of things. Of course, if you want to go, so even it gives you the solution sometimes, but you need to pay for that, okay? But if you want the final answers, that's enough for us. And it is also giving you a lot of things. Okay, so remember this, make it a bookmark in your cell. So if sometimes GeoGebra is not capable, we go here to Wolfram Alpha and try to do some calculations and understand things. Okay, now you understand that 2 to the power 64 is a really, really huge number. Yes? So just be careful about when you are working with huge numbers. With exponential numbers, you are more or less dealing with very huge numbers. Okay, now I will go back to the lesson. Now that was a little bit unfortunate. This frame was not totally in the in the frame, so some part of it was not recorded, but yeah. I just wanted to ask one question for the people who are interested in mathematics. Try, before using Wolfram, try to understand how you could come up with the answer that there are 20 digits there without calculator or computer. Can you find a mathematical reasoning behind this argument that 2 to the power 64 should have 20 digits or whatever it was there? I don't remember exactly. This is a good question for the people who are interested in mathematical problems. Okay, so now let us go back to our lesson. Okay, so something that I want to mention is there is something that is a little bit mysterious. Mathematicians always want to expand the ideas. So they might say that why we should stop for natural numbers, why we cannot take negative numbers, what happens if I take 0, fractions, square roots and put them on top. Okay? The first thing comes to mind is that we cannot follow the same rule for negative numbers, for example. I cannot use the same rule for 0. If I ask you what is a to the power of 0, it is meaningless using this. I cannot say multiply a by itself 0 number of times, which is ridiculous, yes? So we have to come up with an agreement. So a to the power of 0, by the way, I haven't done these two. So let me just finalize these two and go back to the lesson. The new lesson. So here, how should I calculate this, by the way? 2 to the 2 to the 3. How should I do that, yes?
Start with the 2 times 2.
Yes, because that is in the bracket. So I would write a pair of brackets here, 2 times 2 to the power of 3, because the pair of brackets gives the priority to this. Yeah. And then what can I do here? It becomes 4 to the power of 3, and then it means 4 times 4 times 4, and this becomes 64 as before. Yes? And then if I go here, so do you have it in mind? 2 to the power of 5 is? What is that?
32.
Yes, 32. If you don't believe it, start multiplying. But what is this one? This becomes 1 over 2 multiplied by 1 over 2 multiplied by 1 over 2. So 32 plus 1 over 8. And then I want to have the common denominator. So the common denominator would be 8. What is the denominator which is not written? It's 1. So 8 times I have to multiply 256. And 8 to 81 times it's 1. Yes, and then what you do, you add them, it becomes 257 divided by 8. By the way, can you write this fraction just as a mixed fraction? Do you know what's a mixed fraction? A fraction like this probably you have seen in grade school. This is called the mixed fraction. This is called the proper fraction. So remember these words in English. It's a mixed fraction. Can you write this as a mixed fraction for me, please?
You mean
mixed fraction, do you know? I don't know. For example, 2 and a third. What is the meaning of this?
yeah.
So tell me, what is this fraction? If I want to write it as a proper fraction, you please, what's your name? What? No. Yes. Yes, you. Angelina, yes. What is the another name for this?
It's 2 before.
That's an approximate. If you write 2.3333, this is not another name for this. This is an approximate name for this. What is exact name? I want you to write this. This is called the mixed fraction. You have one part and a fraction. This is called the mixed fraction. Can I write it as one single fraction?
Yes.
Not a mixed one. Can you yourself answer this still?
Yeah, you just like multiply 2.
Okay. 2 by 3, 6, and you add 1, 7. Yes, thank you. So it becomes 7 over 3. That's another name. Yes? Now I'm asking you the opposite question. This is already in a proper form. I want you to write it in the mixed form. Yes?
I think I know.
Yes?
32 and 3 over 8. Something.
Exactly. That's it. It's 32, 1 over 8. Yes? This is the mixed form of that. But be careful. This is the first time, it's a little bit unusual. This is the first time that you do not see any sign, because when you write A, B without any signs between them, it means that they are being multiplied.
Yeah.
But this is the first time that you do not see sign between this one and that one, but this shouldn't be interpreted as multiplication. It should be interpreted as addition. Yes? So be careful. When you say A, B over C as a mixed fraction, it means A plus B over C. And if you want to write it as a single fraction, what you need to do, you need to take the common denominator, so it becomes AC, and then plus B over C, and then add them. So it becomes AC plus B divided by C. So if you want to put this mixed fraction in a form of a proper fraction, this is the rule. And the rule of thumb is to multiply this in your head by that and add this to this and put it here. 3 times 2 plus 1, 7, and 3. Okay, let us put this aside. Okay, now let me go back. These are fundamental things. I think you need to really know them. And there are good exercises in the book. So if you think you have a little bit of weakness or you have forgot something about these, please read the first few pages in the book. There are good reviews on that. Okay, now the first thing comes is a convention. So if A is not equal to 0, please write it down. If A is not equal to 0, then A to the power of 0, I cannot follow this rule because it is meaningless. Multiplying A by itself 0 number of times. But whenever you see this, the answer is 1. You might say, why 1, not 2? Because we have chosen this. That's a reasonable question. But do you remember I talked a little bit about prime numbers and I told you that 1 is not a prime number? Because if I admit that 1 is a prime number, then I will have a little bit of trouble later. So we come to an agreement, forget about that 1 is a prime number. That's a convention. So for the time being, let us take this as a convention, but this is a reasonable question. Why we have this agreement? Why we do not agree on this, that A to the power of 0 is 2? We could in principle have that agreement. Okay? I will answer this question a little bit later, okay? But for the time being, if A is not equal to 0, this is equal to 1. So for example, if I ask you to calculate this 1 for me, so what's the answer? Yes? It's 3, yes? Because this is a number which is not 0 raised to power 0. This part is 1. This is also of this type. That is also 1. How complicated that is that? Who cares? This number to power 0 is also 1. So the answer would be 3. Is that understandable? So this you need to, for the time being, might be you are not very happy why I should define this if you are very curious mathematically, but let us keep it like that. The next step, so you remember I started from natural numbers for the power 1, 2, 3, 4. And I have an agreement what I do with 0. The next natural question is that what should I do with negative numbers? Yes, I know what happens for the 0, 1, 2, 3, etc. But let us go below them. -1, -2, -3. I did it for you last time. Do you remember? So now I want to extend the idea of powers to include negative exponents as well. So my question is that if you see this in a math book, what do they mean by this symbol? They mean 1 over 2 to the power of positive 1. This is the meaning of this symbol. Instead of writing this symbol, which is a little bit more expanded, you write it more compactly like that. Okay, and then if I ask you, what can you tell about this, you would say it's 1 over 2 to the 1 is 2. That's over 1 over 2. If you want to, here you can write 0.5. So this is nothing except 1/2. But I always prefer, in high school, to work with fractions. If the fractions is exact, I don't bother. If you want to, you can write 0.5. But if I give you in the exam this, and you write this instead, this is not acceptable for me, because this is not equality. This is approximation. Yes, so be careful about that. So if that's the exact value, feel free if you want to work with decimals. Otherwise, have to work with fractions. So here, if I give you 2 to the power of -2, what would be the answer? So it would be 1 over 2 to the power of +2. So already know what to do with this. It is 2 times 2, but it becomes 1 over 4. Yes?
I have a question.
Yes, please.
So, like there, would we lose a mark for not using the appropriate sign? Like if we use the equal sign instead of out of.
If you don't use the equality,
No. As in, so you have 1/3 there.
where is 1/3? Where is?
On the top. On top.
Yeah, here.
Yeah, if we don't, like, let's say I use the equal sign, would we lose a mark then?
Yes, definitely. Because I told you 1 over 3 is not equal to 0.33. It's approximately equal to 0.33. Yes?
But for example, the one with 1 over 4, you can write.
No, if you write here 0.25, I actually accept it because that's exact value.
Yeah.
Yes? But if it's not exact and you write it exactly equal, you are making an error mathematically.
But I can write that. What's the mark called? Not the equal to sign, but the almost equal to.
Approximate. Yes. This 1 over 3 is approximately equal to that.
Yeah.
That's
so
how
I
you
can
read
use-
it.
So I can use that sign during an exam.
If I don't ask you to give me the exact value, usually in my questions I write it in italic, give me the exact value.
Okay.
If I write and give you exact value, even if you write approximately this, then I will not accept that because it's not possible. Yes?
Yeah,
It's
that-
not.
I understand.
Okay, so here, and if I ask you what is 2 to the power of -1 over 3, to the power of -3, so it becomes 1 over 2 to the power of 3, then it becomes 1 over 2 times 2 times 2, which is 1 over 8. Yes? So now, instead of giving you examples, I want to add this, so you need to have it in mind. Unfortunately, in the Swedish system, you have all these formulas in the formula sheet, even if you go to Math 4 and 5. Which is a little bit unusual. Try to use your memory. This is my real advice. So for example, if you are familiar with Anki website that I introduced you, you can start making your own flashcards today. Okay? So for example, you write a to the power of 0 equals to question mark, and in the back of the flashcard you write 1, and then try to study. Sooner or later it will go into your memory, okay? But you need to be a little bit disciplined. Whenever you want to study, the first thing that you need to do is to review your flashcards and then start the new study. That's the algorithm. Otherwise, the algorithm is not that efficient. Okay, so now I would say that if a to the power of -n, if you see this symbol, what is the meaning of this if n is positive? If n is a natural number but you have a negative sign here, then what you do, you write 1 divided by a to the power of n. But here I have to have a limitation for a. So far I didn't have any limitation for the base, but here I have to have a limitation for my base. There is an exception to this. What's that exception? Yes, Sergey? 0. A shouldn't be 0. If a is 0, 1 divided by 0 is not defined. So n belongs to n. A is not equal to 0, then I have this formula. Yes? Okay, now let me ask you this question. How can I calculate this? If I have 2, let me start from here. 1 over 3 to the power of -1. So what is the answer to this? I'll have to follow the rule. I see this is my base. Is this base acceptable? Yes. The only exception for negative powers is 0, and 1 over 3 is not 0. So I am on the safe side. So what is the answer to this? It should be 1 divided by a. This is playing the role of my a. But to the power of what? Can you tell me? 1. So I just want to wait. Everybody understands what's going on here? This 1 over 3 is playing the role of a. That 1 is playing the role of n. I'm using this formula. Yes? But if I continue this calculation, for the 1, I don't have any other options, so I have to copy and paste that. But there is a better way of writing this guy. What is a better way? 1 over 3 to the first. Yes, please.
1 over 1/3.
Yes, so it becomes 1 over 1/3. And now 1 divided by 1 over 1/3. First, let me ask you, do you know what's the answer?
Yes.
What's that?
3.
It's 3. And I will explain if still you don't understand it quite well. So I want to see why 1 over 1 over 3 is 3. Because first of all, it is the reciprocal of 1 over 3. So it means that I have to interchange the role of numerator and denominator. In principle, it becomes 3 over 1, but 3 over 1 is the same as 3. So this is one way of understanding that. Another way of understanding is I want to write 1 divided by 1 over 3. It means, another way of writing means 1 divided by 1 over 3. But you already know that in your previous studies. If I want to divide, I write 1, I change this to multiplication, and then I interchange the role of these two. So 3 goes up, 1 goes down, and then I will start multiplying them. So what would be the answer? 3. Yes? But I really want this to send it to your memory. So 1 over, can you tell me what happens for this rule? Immediately. 1 over A over B. B over A. Yes. So, yeah. Of course, I want you to understand that. But sooner or later, you should be quick and fast. This is like driving, you know. In the driving, you can think about when I have to change the gear or something. But if you want to think about how to drive all the time, you will not feel, you don't enjoy driving. You can enjoy driving when it comes automatically, yes? So that's the same thing. If you want to calculate everything from scratch all over again, that's not fun. Okay, let me give you another example. So I will give you here 2/3 to the power of -3, and I want to give me the exact value without any exponents. I want to wait for you. Just do it. Yeah, do it as quick as possible. Yes? 2 over 3 to the power of -3. I want you to write down all steps. Yes, please.
May I use the bathroom?
Of course. If you don't mind, I will write some more for you here, so you can just do it yourself and then give me the answer. So let me call this number 1, number 2. Yeah, let us do these things. I wait for you. Continue recording. Okay, so how should I calculate this? The first thing comes in mind, I need to write 1 if I want to write all the details. 1 over 2/3 to the power of 3. And then I will copy and paste this one. I cannot do anything with that, but I can go further with this. Of course, we will study rules for this later, but for the time being, I have to follow only one rule, and that's the definition. So again, I copy and paste 1. Can you answer this in your head? 2 times 2 times 2? 8, and the denominator? 27. What we just learned, you really don't need to spend time. What's the answer to this combination?
27 over 8.
Yes, thank you. You just stop there. That's it. Okay, let us do this one. So this becomes 1 over. I will take this in the denominator. Do I get rid of this minus sign or that minus sign? Not this one yet.
No.
Yes, this one. Yes, so it becomes minus 2 to the power of positive 2. And now if I ask you what is this, I have to copy and paste the numerator here. I have to write minus 2 times minus 2 times minus 2. This is also a good way of writing. You don't need to put brackets. Even if you put brackets, that's okay. But what's the answer to this combination? Minus 8. It becomes 1 over minus 8. I myself, this is completely okay to stop here. I myself prefer to put the minus sign in front. So I would myself prefer, I care about beauty actually, so I would write it in this way. So you know that it doesn't matter if you write minus a over b, or if you write a over minus b, or if you write minus a over b. All of them are the same and acceptable. But I myself prefer to write this. That's up to you. If you stop here, that's completely okay with me as well. And if you have any questions, please let me know. So the answer to this is minus 1 over 8. So here, what should I do? The same story, so let me just do it quicker. So this minus 2 remains, and I have positive 4. Then you know that this is minus 2 times minus 2 times minus 2 times minus 2, which is 1 over 16. Am I right?
Yes.
Thank you. Now here, what should I do here? Yes, please.
So we start as usual, right?
Okay, so just tell me step by step. What is the first thing that I have to write?
1 over minus 3 to the power of 3.
No. Be careful. Because this minus sign is not under the influence of this power. It's not in the brackets. Pay attention to these details, okay? So if I want to do this, I have to keep the minus sign here.
Yeah.
Because minus 3 is only affecting this 3. And then I would write 1, and I will take it down, so it becomes 3 to the power of 3. Might be, your answer will actually be the same at the end. But it is very important, if I ask you to write the steps, you need to do you need to do it in valid ways. So is that understandable for everyone? You have to keep this minus sign here.
Yes.
This minus sign is not under the influence of the exponent, because it's not in the pair of brackets. So it means that I have to copy paste this negative sign. I have to copy paste and this fraction line, copy paste 1, and then you can do it in your head. 3 to the 3, 27. That's it. So how can I do this one here? So can you help me to do that?
You
Yes, please.
have to first
What's your name?
Hafsha.
Hafsha, yes?
You have to put what's inside the parent.
So I put equality. I still keep this bigger pair of brackets, and I keep this one, and as Hafsha said, I will just do this one. I think it's now better to do it in our head, because we are experienced now. Minus 2 to the 2, what's the answer? 4. So do you mind if I just put 4 directly? So if I put 4 directly, do I really need to bother about this pair of brackets? No. So let us get rid of that. So I come from here. That's, by the way, that's completely okay for me in the exam if you do it fast. But I want you to really understand and do it fast. Is that understandable for everyone? Okay. Now, this is the new rule. How should I continue, Hafsha?
Then you have to do 1 over 4 to the power of 3.
Yes. And then this you can do it in your head again. Copy paste 1. 4 to the 3. Actually, the correct way of reading it is 4 to the 3rd. Americans read it in this. But if I sometimes say 4 to the 3, that's also acceptable, hopefully for you. So 4 to the 3 is what? 64. And then I copy and paste it here. Good. So can you have a rule of thumb about this scenario? If I have a fraction and I give you minus 3, if I want to write it with positive exponent, can you have a rule of thumb to do it quickly? Of course, you can start everything from scratch, but I want you to have a, I don't know, I have this feeling might be, because when I was growing up in Iran, we have, for entering the university, you have to do a lot of exams, and you have to do them very fast. Every question, 60 seconds, 90 seconds. So I don't know, intentionally I want to do it faster. But I believe that doing it faster is good, even if you don't face that kind of exam here. Because if you don't care about the speed, you will not care about memories, you will not care about being fast. Okay, so how should we do that here? Yes?
3 over 8 to 3.
Yes, thank you very much. So it's much easier to remember these rules of thumb. So if I have a fraction to a negative power, if I want to get rid of the negative sign of that power, I can just interchange the numerator and the denominator and make it positive. But even though I do it quickly, if one of you asks me why I do this, I can explain it to you. If you just memorize it in that way, if some of the students from other schools ask you, do you know why? If you say no, that is a shame. So if you want to use something, you really need to be able to explain it, but not necessarily everything for yourself. Can you tell me why this is correct? Why do you think this is correct? Let us try to convince ourselves that this fast method will always work. Let me just do it for minus 3 here. So I will start from the left hand side, and I have a over b to the power of minus 3. So what can I do for negative power? I have only one thing that I can do. I can use the definition. I would write 1 on top, I will write a over b, and then I will write it to the power of 3. Yes? Then what can I do? I can write 1 over a over b multiplied by a over b multiplied by a over b. But then this becomes 1 over a times a times a is
3a.
not 3a. Be careful. A to the 3, yes? B times b times b, b to the 3. When it becomes, can you answer this question? When it becomes 3a? Yes?
When it's like 3 times A.
Yes, but when? Yes?
When it's addition.
And it's addition. If a, remember, a times a plus a plus a. What is the answer to this? 3a. What's the answer to this? A to the 3rd. So be careful about that, yes? So this becomes a to the 3, b to the 3. Okay, now can you immediately answer this for me, because we already talked about that? 1 over a fraction. Yes?
Isn't it 1 multiplied by...
No, you are yes, of course that's true, but I want you to use your memory. Did you listen? So you see, you forget immediately. This is what I want you to fix. Yes?
B3 over A3.
A3. And if you say why, then that is your explanation. I don't want you to say why to me all the time. Yes, it's good. Do it until you yourself believe that you understand it. When you understand it, just use it. Yes? Okay. So, we understood that I have the reciprocal of a fraction, it becomes the other way around. Do you agree?
Yes.
And now let me continue. Do you agree that instead of b to the 3 over a to the 3, I can repeat it like this or not? Do you agree that b to the 3 over a to the 3 is equal to this? Yes? And now, what can I write for this? I have a number being multiplied by itself. How many times? 3 times. So it becomes b over a to the power of 3. And this is exactly the right-hand side. So I started from the left-hand side of this equality, which I was not sure about. And step by step, using valid arguments, I reached to the right-hand side. This is one simple example of what we call mathematical proof. Yes? And so this is something, this is a statement which we didn't know is true or false, but we were able to start from the left-hand side, and I followed all the mathematical rules here, which are valid, and I reached to the other side. So it means that I proved for you that the left-hand side is equal to the right-hand side. Okay, that's up to you if you want to have them in your memory or you just leave it here. But let me write this one for you as well. So now can you tell me, according to that rule, exactly similar, what can I write immediately for this if I want to get rid of this negative sign? Yes, please, what's your name?
Melker.
What?
Melker.
Melker, okay. Please.
Isn't it b over a to the power of n?
Yes, exactly. So these kinds of rules, even though they are not written in your book, if you write for me in the exam, that's okay with me. Yes? So that's up to you. Of course, make sure that you understand it, but then try to use it. And then, of course, by using it so many times, you will remember them. Okay. There is something more that whenever you describe a concept in mathematics, mathematicians try to see that if they can invent new rules for that new concept. Okay? So what do I mean? If I give you, it turns out, so for example, if I give you 2 to the power of 2 plus 2 to the power of 3, if I ask you to calculate this, you really don't need any extra rule. If I give you this, you still don't need any extra rule. So what's the answer to this? It's 4 plus 8 is 12. Here it is 4 multiplied by 8, it is 32. So you don't need any rules. Yes? But sometimes rules are important. Why is that? For example, I give you a fraction like this. I write 2 to the power of 100. So you now should have a very huge respect to this number, you remember. And I multiply it by 2 to the power of 3. And then I divide it by 2 to the power of, I don't know, 90. And then I multiply it by 2 to the power of 12. These kinds of things happen in physics, in chemistry, a lot of places. Of course, in principle, you don't need any rules for calculating this, yes? Because if you are so patient, you should start multiplying 2 100 times, and you multiply 2 3 times, and then multiply the answers and do these things. It's in principle possible, but not efficient at all. So this is why if we have invented some rules that we can apply, that is much better. Okay? So you see, I just want to motivate you that here, if you want to give me the answer, this is possible, but is there any rule that I can simplify this without directly answering that? The answer in this case is yes, but in that case is no. Okay? Yes, do you want to say something? Yes? So here, 2 to the power of 2 plus 2 to the power of 3, we calculated is 12. If I ask you calculate this or evaluate this, You answer me this. But do you think that I can set up a rule here? Yes? Yes, what? Because 2 to the power of 2 means what?
4.
No, not 4. Means what? Answer is 4. It means 2 times 2. This is the meaning of the first factor. And then multiply this multiplication. 2 to the power of 3 is 2 times 2 times 2. And now you see a bunch of 2's, one after the other. But how many 2's you see in this sequence? Yes?
5.
5. Is there another name for this? Yes. Yes, everyone. 2 to the 5. So now you find a rule of thumb. If I have 2 to power 2 and multiply it by 2 to power 3, I can write it 2 to power 5. If you ask me what is, did I evaluate this? No. The evaluation is just the previous number. 32 is the value of this. But before evaluating, I was able to show whatever this number is, they are equal without knowing the value of each one of them. You might say that this is not useful, but it is. It is very useful. For example, in this case, what can I write for this one? 2 to the power everyone. 103. What can I write for this one? 2 to the power of 102. 2 to the power of 103 has 103 2's. And this has 102 2's. So all of them are cancelled except 1. So this would be 2. Okay? So you see the rules are good. So for example, let me make it simple. Let me make it 13 for the time being. And then I will come back to this. If I calculate this, it becomes how much? 103. And what is this answer?
2.
No, this answer.
1.
The new one is 1. Because who cares this number? Every number divided by itself is 1. So you see that rules are important to know. Because sometimes it gives me the opportunity to simplify without evaluating. If you ask me, do you, Babak, know about this number, I would say no. Might be I know about this, it's 8, but the other one I don't know. But without knowing the value of these numbers, I was able to evaluate the whole package, which was my goal. And that was exactly equal to 1. So this is why rules become important. Otherwise, you can start everything from scratch every time. If I ask you to calculate this, you just multiply 200 times, that's the number, you already know that. So this is why we want to add some rules or new calculations. Okay? I will not start this one because might be you're still a little bit tired, so I will stop here. So our lesson is actually up to the rules of these exponents, yes? But the next thing that we will discuss a little bit about, if you write this in your calculator on Wolfram, you get a number. This is a big question. How Wolfram Alpha knows the answer for this? Yes? And then if you write this in Wolfram Alpha, you get again an answer. These are a little bit more advanced topics, especially this one. It's out of this high school actually studies. I will tell you how to feel about these things. But these are the questions. We learned about natural powers. We learned about 0 as a power. We learned about negative integers as powers. But what are the type of numbers left? Fractional numbers are left. The squaring numbers are left. So still we want to give feeling. But the good news is that whatever rule we have for these simple cases will remain valid even for these non-trivial cases. So that is a real point of relief for us. So when you face any kind of exponent, don't be bothered about the type of the exponent. All the rules are always the same. Okay? So I will stop the lesson here today, right now. And then, of course, I have started uploading these videos to the YouTube channel, so you can follow them. And I will give you the link on Google Classroom, okay? Are you following me or not on Google Classroom? So every time I tell you which pages to read and things like that. Okay, thank you very much, and have a nice day.